Hello everyone, welcome to the next is now. I am Aluk Kumar and today we are going to learn linked list in data structures and algorithm. Today we will learn linked list in data structures. Linked list is a collection of nodes connected with each other and all of them are pointing to their next element with a pointer. Here as you can see there are multiple memory blocks like this is one, this is two. Right, so there are multiple memory blocks. Whenever we allocate memory, so it get assigned to particular block. Okay, here you can see it get assigned to particular block. Okay, and our data is kept inside that block. After that, again when we try to allocate the memory to block, it gets allocated to another block, but the blocks cannot be contiguous. Okay, since the disk free space can be anywhere, it cannot be contiguous. Okay, it can be anywhere, so we need to link one block with another using pointer. Okay, using the address of another block. Okay, but before proceeding further with linked list, let us have a look on a array which we had discussed previously. Here we have saw that array is a contiguous memory allocation. So whenever we allocate an array, it occupies block of memories which we had derived early when declaring the array. That's why it is contiguous. Each blocks are next to each other. Okay, but in the case of linked list, it's not possible because we are defining each block whenever we initialize. Array is static form of declaration while linked list is dynamic form of declaration. Okay, so in linked list, whenever we input a data, it allocates a memory block and then it put data into it. Then it connects previous node with this current node. Okay, it is the difference between array and the linked list. Okay, let's come to our main topic, which is linked list. So here as you can see, first when we try to input the data, memory gets assigned to this memory block. Okay, and then again when we try, input the data, it gets assigned to this block. Okay, and then we connected this block with this block using pointer. Okay, we will see how it works, but currently I'm just giving a overview of it. So now again when we try to initialize, so it gets allocated to this and this one is connected with this using pointer. Okay, now linked list is also termed as linear data structure. Why linear data structure? Because this element, you can see this element and this element, these both are connected directly. Also this element, it is also connected directly. Okay, whenever element is connected to its next or previous element directly, then it is termed as linear data structure. Here every element should be connected with its previous or its next element directly. Then it will be termed as linear data structure. You can see here this one is directly connected with this and this is connected with this and this is connected with this. This is structure of a linked list. Linked list consists of two things. Number one, data. Okay, data can be of any data type like int type, float, char. Okay, it's the data which user inputs. Okay, another thing is pointer. I named it next. It can be anything. You can name anything. Okay, so this is the pointer which contains the address of next node. Okay, this node. So this pointer will contain the address of this node, so that when we try to iterate, This will help us to point this node. Okay. So the first node is termed as head. Okay, we call it head, and you can see here how we put the address of next node into the pointer. Okay, first we initialize it and then we put it. We will discuss how what should be the type of pointer and how it initializes. Okay, so after that, again in the next node it will contain the address of another node, this node. Okay, but the last node, it contains null. Okay, it contains null. Okay, star next will be here also, but its value will be null, means there is no node after this. Okay, there is no node after this, that's why it will contain null. Okay, if there will be any node after this, then it should contain its address, but currently no node, that's why it's null. Linked list is known as abstract data type. We have seen in our previous video about stack, which is also an abstract data type. So why this linked list is termed as abstract data type? Because it is collection of multiple operations. You can see here insert first, insert, delete first, delete, and traverse. Okay, these are 5 operations and user focuses on the operation rather than the backend process. That's why it is known as abstract data type. Okay, insert first is used to insert the element at the first, means before the head. This is head. Okay, and we are inserting a node before this, so this node will become head and this will become the next node. Okay, another one is insert. In this insert, we insert our node anywhere between or after the node. Okay, inside a linked list. Another one is delete first. In the delete first, we delete the head directly. Okay, we delete head directly, and in delete we delete any node of the linked list. Okay, and traverse is simply iterating in the linked list, going from this node to this node to this node. Okay, now we will move further to the coding part to understand how it works, how to define, and how to initialize the linked list. Coming to the coding part, let's include first a Ustream header file. Okay, now the next header file which we're gonna include is stdlib.h. This is standard library file. It is used here because we are gonna use malloc and create memory dynamically. That's why we had used this library file. Moving further, now we will define a node, structure of a node. Okay, so for that we will use struct keyword and then name it as node. You can name anything. After that, we discussed about two things. Number one is data, which user will input. Let's say it will be of type int. Okay, another one which we had discussed about is a pointer. So the type of pointer should be the structure, and the same structure which we had defined here. Okay, so we will simply write struct node star as per pointer. Next, we are putting type of pointer as int. exploit anything like that. But currently, since this pointer is used to point towards same structure which we have defined here, so that's why it should be the type of this structure only. Okay, now coming to the main function, let's try to allocate memory and input data into the node. First we created pointer naming head, since it will be the first node in our linked list. Okay, let me use using namespace std here also, so that we don't get any further issue. Okay, now let's define a variable named input. Give the value as 50. Okay, and now try to put this value inside this node. Okay, and it will be the first node of the linked list. So how to do that? We'll use head here, and then data equals to input. This operator is used to point to particular variable. Okay, particular variable inside this. Okay, now again we have to put value in next also. It should be null currently because we are not including any further node here. Okay, so I put the value as null. Alright, now we have to assign memory also. So for that we will write here struct node star. By typing struct node star, here we are using struct node star to define the type, and then we'll write malloc. Malloc is used to allocate the memory block, and here we'll type the size of memory block. Since we want the size same as the struct node, so we will type struct node. Okay, we simply write the data type inside the size of function, which will give size of that data type, and then malloc allocates memory according to that. Now let's output the data. Okay, I guess done a mistake. Okay, you can see here data is 50. Okay, which we had input here, and the next address value is 0, since we had put null into here. There is no another block after this, no another node after this. Okay, let's say we want another node also, then what we will do, we will simply use here name it as node 1. Okay, and the same thing we will do for node 1 also. Type here node 1. Let's say it's 80. Okay, and head data we put as input. At next here we will put address of this node. Okay, so we will simply write here node 1. Okay, why we had write node 1 directly? Because node 1 is directly a pointer, it is not a variable. If it is variable, then we had include like ampersand node 1, but currently it is also a pointer, that's why we will write node 1. Okay, now in the node 1 data we put input 1 and node 1 next we will put null. Okay, output, let's output this one also. And let's see the output. So here you can see output as 50 and then this hexadecimal value, after that 80 and 0. So 50 is stored in the head here. Okay, and this is the address of next node which is in hexadecimal format. Okay, and then the 80 which is stored in the next node here, node 1. We will discuss the operations of linked list in our upcoming video. Thank you very much. Have a nice day. If you like our content, then do like, share and subscribe.